Hello students, today we will be going through the topic minimum cost spanning trees. So in this you will be studying what do you mean by a minimum spanning tree problem. Okay, so consider that given n points which are connected in cheapest possible way so that there will be a path between every pair of points. So in a graph represent point by vertice, connections by edges and connection cost by edge weights. So for example, consider this graph where it has A, B, C, D. These are nothing but points also called as vertices. So the connection between A and B is called as connections, or it is also called as edges, and the cost between the connections, that is the connection from A to B. So the weight of that is 1, whereas the weight of the connection A to C is 4. Okay, so now you should know what is a spanning tree. So definition of spanning tree is that a spanning tree of a connected graph is its acyclic subgraph, that is a tree that contains all the vertices of a graph. So we will see one example. So consider this particular graph. So this is not a spanning tree. So why? As I have already told the definition that spanning, if this graph should be a spanning tree, it should be acyclic, which means it should not form a cycle. First condition. Second condition is that it should contain all the vertices. So if you can see the first condition, this particular graph forms a cycle, that is A, C, D, A. So this particular graph forms a cycle. So this is not a spanning tree. Okay, so this is about spanning tree. Now, what is a minimum spanning tree? So a minimum spanning tree of a connected graph is its spanning tree of a smallest weight. Again, consider this example. So what is a minimum spanning tree? If you consider this particular graph, so we can have 3 spanning trees. So the first one is A to B, A to D and C to D. If you see, this is a spanning tree because if you can see here, it has all the vertices. That is the first condition. Second condition is that it doesn't form a cycle. So now what is the weight of this first minimum spanning tree? So that is 1 plus 2 plus 3. That is nothing but weight is 6. Okay, now the second spanning tree. So the second spanning tree is found by the edges A to B, A to C and C to D. So again, weight of this, again this is not a this is a spanning tree because it doesn't form a cycle. Now what is the cost of this? So 5 plus 1 is 6, 7, 8, 9. So total it is 9. Now the third minimum spanning tree is that it is formed by the edges A to B, A to D and A to C. So what is the cost? 5 plus 1, 6, 7, 8. So the weight is 8. So if you consider all the 3, so which is the minimum? So if you can see, the minimum spanning tree of this particular graph is this because it has the minimum cost. So this is called as a minimum spanning tree. So this is the basic of minimum cost spanning tree. So a minimum spanning tree problem is nothing but it is the problem of finding minimum spanning tree for a given weighted connected graph. Now, when I tell about a spanning tree or finding minimum spanning tree, when we take all the examples or all the elements while constructing a minimum spanning tree, there exist some problems. So for example, the first one is the number of spanning trees grows exponentially with graph size. So this is a very small graph. So it is very easy, but consider a graph which is having 100 nodes or 100 points. So it becomes difficult. Secondly, the generating all possible spanning trees for a given graph is not at all a easy task. Okay, these are the two drawbacks whenever you encounter or whenever you try to find a minimum